Hello students and good morning. So now I am doing class for class 12 science. The topic is second order derivative. So in the last online class also we did some problems on second order derivative. So today we will do more important problems on second order derivative. Right? So same exercise 4. Each question carries 4 marks. Page number is 321 from the book Higher Mathematics for Class 12 by SN Day. So question number 6 of question number 3. Okay. So in the last online class, I left this problem number 6. From 5, we did question number 7 of number 3. So today we'll do this sub part number 6 of question number 3. Okay. So find y2 in each of the following cases. That is sin x is equal to 2 tan theta upon 1 plus tan square theta, and cot y is equal to 1 minus tan square theta divided by 2 tan theta. So this is also a parametric equation. That is, both the variables x and y are expressed in terms of a third variable theta. Okay. So in order to differentiate both this equation, you have to use the formula in this case from inverse circular function or from trigonometry, right? So now what is the first given equation here? This is sin x is equal to 2 tan theta divided by 1 plus tan square theta, right? So let us get the value for x out here, or x is equal to, this is your sine inverse 2 tan theta divided by 1 plus tan square theta, or x is equal to sine inverse. Now you know this formula of 2 tan theta upon 1 plus tan square theta from trigonometry. So what is the formula in this case? This is your sine 2 theta. त तिमीले क्लास 11 मा ट्रिगोनोमेट्री मा मल्टिपल एंगल्स मा गरेको हो 2 tan theta upon 1 plus tan square theta भनेको कति हो? sin 2 theta. So this is your sin 2 theta, or x is equal to, what is sin inverse sin 2 theta? You know that what is sin inverse sin 2 theta? Sin inverse sin will be cancelled and you have to write down 2 theta, right? So let us differentiate both the sides with respect to theta. So differentiating both the sides with respect to theta. So therefore dx by d theta is equal to only 2. Is that clear? So this is your number 1. So I think you have understood it. Again you have to find out dy by d theta from the second given equation. Again what is cot y in this case? So it is cot y is equal to 1 minus tan square theta divided by 2 tan theta. Okay. So let us convert this cot into tan, because we know the formula for tan, isn't it? So what is cot in terms of tan? Because if you write in terms of tan, it will be easier for you. If you write cot y in terms of tan y, it will be easier for you to write down formula from tan y. Okay, so that's why we are converting it into tan. So it is 1 by tan y, which is equal to 1 minus tan square theta divided by 2 tan theta. Now let us get the value for tan y. Invert both the sides in this case. So what do we get? This is your tan y is equal to 2 tan theta divided by 1 minus tan square theta. So I think you have understood it. So let us get the value for y in this case. So what is the value for y here? Or y is equal to tan inverse. So within bracket, what do we have? 2 tan theta divided by 1 minus tan square theta, right? Or y is equal to tan inverse. So what is 2 tan theta upon 1 minus tan square theta? This is your tan 2 theta, okay? Or y is equal to tan inverse tan 2 theta is 2 theta, okay? So this is the simplified form for the function of y, that is y is equal to 2 theta. So let us differentiate both the sides with respect to theta. So differentiating both the sides with respect to theta. So therefore this will be dy by d theta. This is also 2. right? So let us mark it as number 2. Now you have to find out dy by dx. So you can divide 2 by 1 to get dy by dx, isn't it? This is your dy by d theta is equal to 2, and this is also dx by d theta is equal to 2. That is number 1. So let us write down dividing 2 by 1. So let us write here dividing 2 by 1, because you have to get the value for dy by dx. So therefore dy by d theta divided by dx by d theta is equal to, what is dy by d theta here? 2 divided by, write down right hand side of number 1, that is also 2. Your 2 gets cancelled, that is your 1, or this is your dy by dx is equal to 1. So we got the value for dy by dx, which is equal to 1. Now again you have to differentiate it both the sides with respect to x to get the value for d2y by dx square. Okay, so now write down again differentiating both the sides with respect to x. Again differentiating both the sides with respect to x. So therefore d square y by dx square is equal to, this is your d by dx of 1. So what is d by dx of 1? It is 0, you know that, right? So or d square y by dx square is equal to 0. So this is the final answer. So I think you have understood the problem. So now we'll do the next question now. So now we'll do the next question, that is for number 1. If y cube is equal to x square plus y square, you have to find out d square y by dx square at y is equal to 1. So in this case you have to find out the value for d2y by dx square at y is equal to 1. But in this case the value for x is not given. त सबभन्दा पहिला हामी के निकाल्छौं, x को भ्यालु निकाल्छौं when y is equal to 1, right? त सबभन्दा पहिला हामी x को भ्यालु निकाल्छौं when y is equal to 1. So यहाँ given के छ, given छ y cube is equal to x square plus y square, right? So putting y is equal to 1, so putting y is equal to 1, therefore 1 whole cube is equal to x square plus 1 whole square. Okay, so 1 is equal to x square plus 1. Here 1 gets cancels. So what is the value for x square, which is equal to 0, or what is the value for x? X is equal to 0. Now wherever there is x and y, after you get the value for d2y by dx square, you have to put x is equal to 0 and y is equal to 1. So let us find out dy by dx first. In order to get the second order derivative, first of all you have to get the value for dy by dx from the given equation. So here again write down given here is y cube is equal to x square plus y square, right? So differentiating both the sides with respect to x. So differentiating both the sides with respect to x, what do we get? Y cube को differentiation कति भयो? With respect to x, 3y square into dy by dx, which is equal to, what is the differentiation of x square? 2x plus what is the differentiation of y square? 2y into dy by dx. Is that clear? So what is the differentiation of y cube? 3y square dy by dx is equal to 2x plus 2y into dy by dx, right? So now let us get the value for dy by dx from here. Now keep the terms containing dy by dx on the left hand side. So or this is your 3y square into dy by dx. Next plus 2y dy by dx taken to the left hand side becomes minus 2y dy by dx, which is equal to, on the right hand side there is 2x. Is that clear? So what is common on the left hand side? You take only dy by dx as common. So or dy by dx is taken as common within bracket 3y square minus 2y, which is equal to 2x. Is that clear? So what is the value for dy by dx now? Or dy by dx is equal to 2x divided by 3y square minus 2y. So this is the value for dy by dx. Okay. Now again you have to differentiate it. But before that, let us get the value for dy by dx when y is equal to 1 and x is equal to 0. Okay. So let us mark it as 1. यसलाई नै हामीले फेरि डिफरेन्शिएट गरेर मात्रै d2y by dx निकाल्छौं. तर let us get the value for dy by dx when y is equal to 1 and x is equal to 0. So at y is equal to 1 and x is equal to what? 0. Okay, let us get the value for dy by dx. So dy by dx is equal to 2 into 0 divided by 3 into 1 whole square minus 2 into 1. So obviously it is dy by dx is equal to 0 by 1 is 0. So dy by dx value कति आयो? 0. तर यसलाई डिफरेन्शिएट गर्ने हैन है, हामीले नम्बर 1 लाई नै डिफरेन्शिएट गर्नुपर्छ. You have to differentiate the equation which is marked as number 1 with respect to x to get d square y by dx square, right? So let us write here from 1, what do we have? Dy by dx is equal to 2x divided by 3y square minus 2y. Now let's differentiate it. So why did you get the value for dy by dx? Why are we getting the value for dy by dx? Because in this case, after differentiation, if you get the value for dy by dx, in that dy by dx, you can put dy by dx is equal to 0, so that it will be easier for you to simplify the value of d square y by dx square, right? So let us differentiate it again with respect to x. So differentiating both the sides with respect to x. So therefore this is your d2y by dx square is equal to, what is here? Now we can use u by v rule. Okay, now you know u by v rule, denominator is kept as it is, that is denominator here is 3y square minus 2y into, now take the differentiation of numerator with respect to x, that is your 2. Is that clear? Then बिचमा के साइन आयो? माइनस. अब केलाई सेम राख्छौ? 2x. 2x is kept as it is, right? Numerator is kept as it is, and within third bracket take the differentiation of the denominator with respect to x. So what is the differentiation of 3y square with respect to x? It is 6y into dy by dx. You know that differentiation of y square is 2y with respect to x. Y co differentiation with respect to x, dy by dx. So this is your 3 to the 6y dy by dx. Minus, then what will you write here? What is the differentiation of 2y with respect to x? 2 into dy by dx. It is differentiation of 3y square minus 2y with respect to x is, first of all, it is 6y into dy by dx. You y square को differentiation कति भयो पहिला? 2y. Again differentiate y with respect to x, that is dy by dx. Minus 2 into dy by dx whole divided by, in the denominator, what do we write? Denominator whole square, that is 3y square minus 2y whole square. Is that clear to all of you? So I think you have understood it. Now no need of simplifying it. अब simplify नगर्ने. एकैचोटी भ्यालु हाल्नु. कुन कुन भ्यालु हाल्न सक्छौ? Y is equal to 1. You can putting y is equal to 1. What was the value for x? X is equal to 0. And just now we got the value for dy by dx, which is also 0. So dy by dx is equal to 0. Now no need of simplifying this expression. Just put these values. You can get the value for d2y by dx square. Okay. So therefore d2y by dx square is equal to, now within bracket, y is equal to 1 is there, 1 whole square, 3 into 1 whole square minus 2 into 1 into 2 minus 2 into 0 within third bracket, 6 into 1 into dy by dx is also 0, minus 2 into 0, third bracket is closed. Is that clear now? Whole divided by, in the denominator, 3 into 1 square minus 2 into 1 whole square. Okay, so let's simplify it once again. So let us simplify it again. Or d2y by dx square, d2y by dx square, which is equal to, now on the right hand side, 3 into 1 whole square is 3. So this is your 3 minus 2, right? 3 minus 2 into 2 minus, so there is 0 here. 0 into any number is always 0. Whole divided by, in the denominator, what do you write? 3 1 whole square is 3 minus 2 is 1. This is a 1 whole square. So if you simplify it, what is the answer? That is, you will get the answer as d2y by dx square is equal to 2. So 2 is the final answer. So you can copy it. Let's do the next question now. So now we'll do the next question, that is question number 4. This is question number 4, number 2. 4, number 2. So if y is equal to x upon x square minus x minus 2 is given, this is a fraction. Find the value of y2 at x is equal to 1. Now in this case, you don't have to get the value for y in this case, because this is, you know that this is an explicit equation or explicit function. That is, if y is expressed in terms of x, then this is an explicit function. Okay, so in this case you don't have to get the value for y when x is equal to 1, because this y is expressed in terms of the function of x. That is, y is expressed in terms of x. Okay, now in this case, before you differentiate this given function, let us convert it into partial fraction, because in this case the denominator can be factorized. You can factorize the denominator, that is, you can convert it into the product of two factors, and then you can convert that fraction, then you can convert that fraction into partial fraction. So you know the meaning of partial fraction. I told you in the last online class what is a partial fraction, isn't it? So let us convert this fraction into partial fraction by factorizing the denominator. So here given is, so what is given in this case? So y is equal to x upon x square minus x minus 2. So you can factorize x square minus x minus 2. You can do the middle term breaking out here. That is middle term breaking. यसमा multiply गर्दा 2 आउनु पर्यो. दुईटा नम्बर multiply गर्दा 2 को अगाडि नेगेटिभ साइन छ भने दुईटा नम्बर सबट्र्याक्ट गर्दा चाहिँ x को अगाडि 1 छ, 1 आउनु पर्यो. That means 2 1s are 2, 2 minus 1 is 1, right? So it is x square minus within bracket 2 minus 1 into x minus 2, right? So is equal to x square minus 2x minus 2 minus plus x minus 2. Okay, so here x is common, x minus 2 plus 1 common, x minus 2, which is equal to x minus 2 into x plus 1. So these are the factors. Okay, so let us write it here. So y is equal to x upon, what are the factors in this case? X minus 2 into x plus 1. Now you know that this x to the power 1, this is also x to the power 1. This is the linear expression in x. Okay, and the power of x, and the highest power of x in the numerator is less than the highest power of x in the denominator. So you can convert into partial fraction by writing. So in the last online class we did this type of problem, that is, we have converted fraction into partial fraction. What was the method? Let x upon x minus 2 into x plus 1 is equal to, here first factor is linear expression in x, and the highest power of x in the numerator is less than the highest power of x in the denominator. So you can write here whatever may be the expression here, whether it is variable or constant, you have to write always constant a divided by first factor. What is the first factor? This is your x minus 2 plus, then what do you write? Some constant b divided by, what is the second factor? It is x plus 1. So this is your number 1. So why is it marked as number 1? Because from this equation you have to get the values of capital A and capital B, and you can put that values of A and B in number 1. That's why it is marked as equation number 1. So let us get the value for A and B. So let us simplify the right hand side, keeping left hand side as it is. X minus 2 into x plus 1, which is equal to, what's the LCM out here? X minus 2 into x plus 1. In the numerator we have A into x plus 1 plus B into, this is your x minus 2. So here you can cancel this. X minus 2 x plus 1 gets cancels, or x is equal to capital A into x plus 1 plus capital B into x minus 2. Is it clear to all of you? Now from this equation you can get the values of capital A and capital B, which is constant. Here the variable is only x. So in order to get the value for capital A, you have to make this second term 0 by putting some values of x. So what should you put for x so that it is 0? X is equal to, if you put x is equal to 2 minus 2 is 0. The second term is 0. You can get the value for A, right? So let us write here, you have to find out here y2. Okay, so putting x is equal to 2, putting x is equal to 2. If you put x is equal to, this 2 minus 2 is 0, this second term is 0, right? So left hand side now becomes, or x is equal to, put x is equal to, 2 is equal to capital A within bracket 3 plus 1, right? This is your 3 plus 1. Is that clear? You put x is equal to 2 in this case. 2, oh sorry, this is 2 plus 1, not 3. This is your 2 plus 1, right? X is equal to 2 plus 1. Is that clear? So what is the value for A in this case? A is equal to 2 by 3. So we have got the value for A by putting x is equal to 2. Now what should you put for x here so that this first term is 0 and you can get the value for B? Minus 1, isn't it? If you put minus 1 here, minus 1 plus 1 is 0. So putting x is equal to minus 1. Putting x is equal to minus 1, right? So therefore this equation now becomes, putting x is equal to minus 1. This is x is equal to minus 1 is equal to, this term will be 0, you don't have to write it, plus b into x is minus 1 minus 2. Minus 1 minus 2, or minus 1 is equal to b into minus 3, or what is the value for capital B, which is equal to 1 upon 3. That is b is equal to 1 upon 3. So we have got a is equal to 2 by 3, b is equal to 1 by 3. Put those values of a and b in equation 1. Okay, putting the values of A and B in number 1, right? So therefore x upon, this is your x minus 2 into x plus 1, x minus 2 into x plus 1, which is equal to, what is capital A? Capital A here is 2 by 3. 2 by 3 divided by, which is the first factor, x minus 2. Then next plus what is the value for capital B? It is 1/3. 1 upon 3 divided by x plus 1. So if you simplify this right hand side, you will get this left hand side. You can check it at home. Okay, तिमीले यो घरमा चेक गर्न सक्छौ. This right hand side लाई simplify गर्दा के निस्किन्छ अरे, left hand side निस्किन्छ. बुझेन? So now instead of this fraction, now we can put this partial fraction. This is known as partial fraction. So now this y becomes now, so now instead of this fraction you put this partial fraction so that it will be easier for you to differentiate it. Okay, so therefore y is equal to, its partial fraction is 2/3 divided by x minus 2 plus 1/3 divided by x plus 1. Okay, now before you differentiate, take x minus 2 and x plus 1 to the numerator. It becomes inverse, isn't it? So or y is equal to 2 by 3 x minus 2 whole to the power minus 1 plus 1/3 x plus 1 whole to the power minus 1. I think you have understood it. Now let us differentiate it. So now differentiating both the sides with respect to x. So it is dy by dx is equal to, it is just like your x to the power n, because x minus 2 is the variable, so this is just like your x to the power n. What is this differentiation? Minus 1 becomes the coefficient, minus 2 by 3 x minus 2 whole to the power minus 2, that is decrease the power by 1 into, again differentiate the term which is assumed as x. हामीले x minus 2 लाई x मा नै लिएको, the x minus 2 को differentiation कति हो? 1 minus 0 which is equal to 1. Since it is 1, you don't have to write 1 out here. Okay, so again differentiate x plus 1 whole to the power minus 1. Again minus 1 becomes the coefficient, minus 1/3 x plus 1 whole to the power minus 2 into 1 is there. How did you get that 1? Differentiate x plus 1 with respect to x, which is equal to 1 plus 0 is equal to 1. Is that understood now? So this is your dy by dx. तो यहाँ into 1 भएको कारणले गर्दा चाहिँ हामीले नलेखेको, ठिकै छ? So यसलाई फेरि हामी डिफरेन्शिएट गर्छौं. So write down, again differentiating both the sides with respect to x. Again differentiating both the sides, again differentiating both the sides with respect to x. Okay, so therefore this is your d2y by dx squared, or you may write it as y2 also, which is equal to, now minus 2 by 3 is constant, you have to keep it as it is because this is constant. Now this is just like x to the power n again, so minus 2 becomes the coefficient again, so minus 2 minus plus 4 by 3, 4 by 3, then x minus 2 whole to the power, again decrease the power by 1, that is minus 3 into 1 will be there. How did you get that 1? Again you have to differentiate x minus 2, which is assumed as x, which is equal to, its differentiation is 1 minus 0, which is equal to 1. The 1 by हामीले नलेख्दा पनि हुन्छ. Then again in this case also you can do similarly here, differentiation, minus 2 becomes the coefficient, minus into minus plus, right? Minus 2 into minus 1/3 plus 2 by 3, then it is x plus 1 whole to the power minus 3, x plus 1 whole to the power minus 3 into 1, into 1. How did you get that 1? Differentiate the term which is assumed as x. Here x plus 1 is assumed as x, that is differentiation of x is 1 plus 1 is 0, 0, 1 plus 0 is always 1. The 1 भएर हामीले लेख्नु पर्दैन यो, ठीक छ? अब यसलाई फेरि तल झारौं, और यसलाई you can write it as y2, which is equal to 4 upon 3x minus 2 whole cube plus 2 upon 3 into x plus 1 whole cube, that is whole to the power minus 3 is simplified and it is written in the denominator. So I think you have understood it. Now you have to put the value for x, which is equal to 1. So putting x is equal to 1. Now put x is equal to 1, what do we get? y2 is equal to 4 upon 3 into 1 minus 2 whole cube plus 2 upon 3 into 1 plus 1 whole cube. Okay, so or y2 is equal to 4 upon 3, this is your minus 1 whole cube plus 2 upon 3 into 2 whole cube. I think you have understood it. Is that clear? Now let's simplify it. So let us simplify it to get the value for y2. So y2 is equal to 4 upon 3 into minus 1 whole cube is minus 1 plus 2 upon 3 into 2 cube is 8, right? So 2 1s are 2, 2 4s are 8. Or y2 is equal to, this is your minus 4 by 3 plus this is your 1 by 4 3s are 12. Or now let's simplify it. y2 is equal to, what's the LCM? 3 and 12, LCM is 12. LCM of 3 and 12 is 12. So this LCM is divided by 3, that is 3 4s are 12. 4 into minus 4 is minus 16, right? 3 ले 12 भाग गर्दा कति भयो? 4. 4 into minus 4 is minus 16 plus, now 12 like 12 ले divide one time, so 1 into 1 is 1. Or y2 is equal to minus 15 upon 12, so you can cancel it by 3. 3 5s are 15, 3 4s are 12. So that means what is the value for y2? y2 is equal to minus 5 upon 4. So this is the final answer. So we can copy it. So now we'll do the next question now. So now we'll do next type of question, that is 5 number 1. If y is equal to x sin x, then you have to prove the equation in terms of first order derivative and second order derivative. This type of question is very, very important. Okay, there are many such type of question out here, so you have to do all these type of questions. These are very, very important because in your HS examination you may get this type of problems. Okay, so now if y is equal to x sin x, you have to prove that x square d2y by dx square minus 2x dy by dx plus within bracket 2 plus x square bracket close into y is equal to 0. So how will you prove it? So in this case, first you find dy by dx and then find out d2y by dx square by differentiating dy by dx and put them on the left hand side including y. You have to put the value for dy by dx, d2y by dx square including y and prove that left hand side is equal to 0. Okay, is that clear now? So given here is, given y is equal to x sin x, right? So differentiating both the sides, with respect to x. So this is your dy by dx is equal to, here uv rule is used, both are the variables, x into sin x, uv rule. Take the differentiation of x, it is 1, keeping sin x as it is, sin x plus, now x is kept as it is, take the differentiation of sin x which is cos x. So this is the value for dy by dx. Again you have to differentiate to get d2y by dx square, right? So again differentiating both the sides with respect to x. So this is your d2y by dx square which is equal to, now this is only sin x, one function is there. What is the differentiation of sin x? It is cos x plus, now this is the product of two different functions, so you have to use the differentiation of uv rule, right? So what is the differentiation of x? 1, keep cos x as it is, you know uv rule, plus x into, now differentiate, x is kept as it is, now differentiate cos x which is minus sin x. Okay, so or this is your d2y by dx square which is equal to cos x plus cos x, 2 cos x plus into minus x sin x. Okay, so now you prove LHS is equal to RHS. Now write on left hand side. So here LHS is equal to x square d2y by dx square minus 2x into dy by dx plus within bracket 2 plus x square into y. बुझ्दैछ? अब हामी भ्यालुजहरु हाल्छौं. So which is equal to x square, what was d2y by dx square? Let us put the value for d2y by dx square is here. Let us put this value. It is 2 cos x, then minus x sin x, right? Next, minus 2x into, what is the value for dy by dx? dy by dx is sin x plus x cos x, bracket closed, then plus within bracket 2 plus x square into, what is the value for y? Y is x sin x. So we have put the values of d2y by dx square, dy by dx as well as y. Is that clear to all of you? So now let us simplify it to prove right hand side which is equal to 0. Okay, so now let us simplify it. So which is equal to, let us simplify it, multiply by x square here, 2x square cos x minus this is your x cube sin x minus 2x sin x, we are multiplying them, 2x square cos x, x square into x minus x cube sin x minus 2x sin x minus into plus minus 2x square cos x, right? Then plus 2x sin x plus x square into x cube sin x. So we have got this expression, just we are multiplying them. Okay, now you can cancel here, 2x square cos x, 2x square cos x will be cancelled, minus x cube sin x plus x cube sin x will be cancelled, minus 2x sin x plus 2x sin x will be cancelled, which is equal to 0. So it is proved. So there are some similar type of question in the book. I'll give you the homework. Okay. So yeah, kotawata esto similar type of questions are in the book. So I'll give you the homework so you can do it at home. Okay. So I'll give you the homework now. Then after that we'll do more problems. Okay. So you can copy it. So now we'll do the next question, that is 5 number 2. This 10 number 1 is your homework. It is same as problem number 5.1. We just did it, isn't it? That is left hand side is equal to right hand side. So in 10 number 1, this is your homework. If y is equal to x square cos x, prove that x square y2 minus 4x y1 plus x square plus 6 into y is equal to 0. So y1 means dy by dx, y2 means d2y by dx square. First of all, you find out dy by dx from here, then get d2y by dx square in order to get y2 and y1, and put those values of y2, y1 and y on the left hand side and prove that left hand side is equal to 0. So you can do it. This is your homework. Now let's do question number 5 number 2 out here. Okay. So if y is equal to a e to the power mx plus b cos mx, then prove that you have to prove this equation. That is in terms of second order derivative. That is d2y by dx square plus m square y is equal to 2a m square e to the power mx. Right? So from given, you have to prove this relation. Okay? So here given is, so what is given here? Y is equal to a e to the power mx plus b cos mx. So differentiating both the sides, with respect to x. So let us get dy by dx here. So dy by dx is equal to, in this case a is constant here, a is kept as it is. What is the differentiation of e to the power mx? E to the power mx into m. Is that clear? E to the power mx into m plus b into, what is the differentiation of cos mx? Minus sin mx into m. Minus sin mx into m. Okay. So, or this is your dy by dx is equal to am e to the power mx. So plus into minus, minus, write on bm, then it is sin mx. Is that understood? Now this is your dy by dx. Again differentiate it to get the value for d2y by dx square. Okay. So now again differentiating both the sides with respect to x. Okay. Now this left hand side now becomes d2y by dx square is equal to, now differentiate e to the power mx, keeping am as it is because am is constant. So am, what is the differentiation of e to the power mx? E to the power mx into m, as you know that. You know this one, isn't it? Then minus also bm is kept as it is into, what is the differentiation of sin mx? You have to take it as sin x. So sin x differentiation is cos mx into, now differentiate mx with respect to x, which is m. So I think, is that clear to all of you? So now, or d2y by dx square is equal to, now you have to simplify it, am square e to the power mx, then it is minus bm square, this is your cos mx. So I think you have understood it. Okay, but in this case you have to prove that d2y by dx square plus m square y is equal to 2am square e to the power mx. Okay, now here we have minus b square minus m square b cos mx. Since as there is no cos here, you have to eliminate this cos mx, isn't it? So from given you can put the value for b cos mx. So how can you get the value for b cos mx? If you get the value for b cos mx, what will be the value for b cos mx? It is y minus a e to the power mx, isn't it? Understood? What is the value for b cos mx from given? It is y a e to the power mx is taken to the left hand side, becomes minus a e to the power mx. So what is the value for b cos mx? It is y minus a e to the power mx. Is that clear? So, or let us write here d2y by dx square. This is your d2y by dx square is equal to am square e to the power mx minus, let us write it as m square b cos mx. Is that clear? So let us put this b cos mx within bracket. Now put the value for b cos mx. We can put the value for b cos mx here now, or it is d2y by dx square, which is equal to am square e to the power mx minus m square and within bracket. So what is the value for b cos mx? From given you can put the value for b cos mx. What is the value for b cos mx? I already told you that it is y a e to the power mx is taken to the left hand side, becomes minus a e to the power mx. So it is y minus a e to the power mx. Is that clear? So from given, what is the value for b cos mx? It is y minus a e to the power mx. So we put that value instead of b cos mx. So let us simplify it. Or d2y by dx square is equal to am square e to the power mx minus, this is your m square y minus minus plus am square e to the power mx. I think you have understood it. Okay. Now let us take this minus m square y to the left hand side, because you have to prove d2y by dx square plus m square y. Okay. Or d2y by dx square plus m square y is equal to, this minus m square y is taken to the left hand side, becomes plus, and these are the same expression, same sign, you can add them, am square e to the power mx plus am square e to the power mx. How much is it? 2a am square e to the power mx. Is that proved? Yes, it is proved. So I think you have understood it. So you can copy it. Now we'll do the next question. This is your homework. You can also copy this question and you can do it at home. 10 number 1. Okay. So copy it. We'll do the next question. So now this 6 number 1 and 6 number 2 are similar type of questions. So 6 number 2 will be a homework. Now from given you have to prove the required relation. So in 5 number 1, in that case we found out both the values of y1 and y2, and we put those values of y1, y2 including y on the left hand side, and we proved left hand side is equal to right hand side. त कतिवटा प्रब्लममा चाहिँ यो मेथड युज गर्यो भने एकदमै अप्ठ्यारो पर्छ। जस्तै यो क्वेशन छ, यो कतिवटा क्वेशनमा चाहिँ एलएचएस इज इक्वल आरएचएस प्रुभ गर्नु एकदमै अप्ठ्यारो पर्छ। त गिभनबाट नै हामी डाइरेक्टली यो रिलेसन निकाल्छ। अब फ्रम गिभन यु हैव टु प्रुभ दिस रिलेसन डाइरेक्टली। सो 6 number 1 and 6 number 2 are of similar type of question. I'll do 6 number 1. So this 6 number 2 will be a homework, right? So let us first do 6 number 1. So what is 6 number 1? What is given? If y is equal to e to the power minus x into sin x plus cos x, then so that y2 plus 2y1 plus 2y is equal to 0. You know that y1 is equal to dy by dx and y2 भनेपछि के हो? d2y by dx square or d square y by dx square. So from given directly you can prove it. Okay? So let us use this method. So here given is, so here given is y is equal to e to the power minus x within bracket sin x plus cos x. Okay, so let us differentiate it to get the value for dy by dx. Okay, So differentiating both the sides with respect to x. So therefore dy by dx is equal to, now we can use UV rule here. E to the power minus x is taken as u and sin x plus cos x is taken as v. So this is your UV rule, right? So let us use UV rule here. So now what is the differentiation of e to the power minus x? It is e to the power minus x into minus 1, isn't it? So this will be minus e to the power minus x, keeping sin x plus cos x as it is. Sin x plus cos x, same was here. Now again plus, first term is kept as it is, e to the power minus x is kept as it is. Now simplify or differentiate the second term. What is the differentiation of sin x? It is cos x. And what is the differentiation of cos x? It is minus sin x. Is that clear now? So now in this case we have dy by dx. Again you can simplify it further, is equal to minus. Actually what is this value from given? It is y, isn't it? That is e to the power minus x, sin x plus cos x is y. So we can write instead of e to the power minus x, sin x plus cos x as y. So it is minus y plus e to the power minus x and within bracket cos x minus sin x. Is that clear to all of you? So again you have to differentiate it to prove y2 plus 2y1 plus 2y is equal to 0. So before that, keep the terms containing y on the left hand side. U minus y laponi, I mean left side my lanso. So what do we get now? So dy by dx plus y is equal to, minus y becomes plus y on the left hand side. So it is e to the power minus x, within bracket it is cos x minus sin x. Is that clear now? So let us mark it as number 1, because we may use the value of this right hand side. That is, we may use the value of e to the power minus x into cos x minus sin x as dy by dx plus y. Okay, so again you have to differentiate both the sides with respect to x. So now let us write here, again differentiating both the sides with respect to x. So it becomes now d2y by dx square plus, what is the differentiation of y with respect to x? It is dy by dx is equal to, now you have to differentiate right hand side. So this is the product of two functions. You can use UV rule now. Now differentiate e to the power minus x, keeping cos x minus sin x as it is. What is the differentiation of e to the power minus x? E to the power minus x into minus 1, you know that. Minus e to the power minus x, within bracket it is cos x minus sin x. Is that clear now? Then comes plus sign. Then you have to write plus sign, UV rule. So now e to the power minus x is kept as it is. So within bracket you have to differentiate cos x minus sin x. Now what is the differentiation of cos x? Minus sin x minus, what is the differentiation of sin x? It is cos x. Is that clear now? So now let us simplify it again. Or now this is your d2y by dx square plus dy by dx is equal to, this is minus sign, right? Now again you can put the value for e to the power minus x into cos x minus sin x from 1. That's why it is marked as number 1. So what is the value for e to the power minus x into cos x minus sin x? It is dy by dx plus y. So minus, within bracket you write dy by dx plus y. Is it clear now? Next, what is common here? Minus, you can take it outside, minus e to the power minus x, within bracket sin x plus cos x. Is that clear? So next, what will you do now? Or this is your d2y by dx square plus dy by dx is equal to, now multiply by minus sign here, minus dy by dx, minus into plus, minus y here, minus, what can you write instead of e to the power minus x into sin x plus cos x? What is this value from given? It is y, isn't it? So write down minus y. Is that clear? So let us take the terms on the right hand side to the left hand side. You जुन चाहिँ right hand side मा term छ त्यसलाई हामी के भन्छौँ left side मा, or d2y by dx square plus dy by dx. Now minus dy by dx on the left hand side becomes plus dy by dx, and this is your minus y becomes plus y, which is equal to 0. So I think you have understood it. Let us simplify it. So let us simplify it once again. Or this is your d2y by dx square. Next, plus dy by dx is 2 into dy by dx. Then plus y is 2y, which is equal to 0. Is it clear now? So now, अब question मा तिमीलाई question मा के दिएको छ त्यस्तै लेख्नु. Question मा y2 y1 दिएको छ भने y2 y1 नै लेख्नु पर्छ. So or what is d2y by dx square? It is y2. यतिकै आन्सर राख्दा पनि हुन्छ, तर question मा जस्तो छ त्यस्तै लेख्नु. So d2y by dx square is y2 plus it is 2y1 plus dy by dx here is y1 plus 2y, which is equal to 0. So this is your final answer, which is proved. Is that clear to all of you? So this is your final answer. Okay. Now similarly you can do this 6 number 2. 6 number 2 is same as 6 number 1. Your number 1 जस्तै तिमीले 6 number 2 homework मा गर्न सक्छौ. बुझ्यौ? Now we'll do the next question now. So now we'll do the next question, that is question number 7. If y is equal to x cube log of 1 by x, prove that x y2 minus 2y1 plus 3x square is equal to 0. As you know that y1 is dy by dx and y2 is d2y by dx square. Okay, so from given you have to prove that relation. So let us prove it from given, directly the given relation. Okay. So here given is y is equal to x cube log 1 by x. So 1 by x can be written as x to the power minus 1, right? Or y is equal to x cube log x to the power minus 1. Now because of this log, this minus 1 becomes the coefficient. Minus 1 becomes the coefficient. The minus 1 चाहिँ अगाडि आउँछ. Log ले गर्दा y is equal to minus x cube log x. Now we will differentiate both the sides with respect to x to get dy by dx. So differentiating both the sides with respect to x. So this is your dy by dx is equal to, now you can use your UV rule. This is the product of two functions. So minus within second bracket. Let us differentiate x cube first, keeping log x as it is. What is the differentiation of x cube? 3x square log x plus x cube remains as it is into, what is the differentiation of log x? 1 upon x, right? So or dy by dx is equal to, multiply by minus sign here, it is minus 3x square log x minus into plus minus यो x ले x cube लाई cancel गर्दा हुन्छ. If you cancel this x cube by x, it is minus x square. Did you understand this one? So minus into plus is minus. You can cancel this x cube by x, it goes x square times. Okay. So now what will you do here is, since there is x cube log x, if you have x cube log x, then you can write it as minus y, isn't it? So minus is taken to the left hand side to make it minus y. So what is the value for x cube log x? It is minus y. Let us make it x cube. So how can you make it x cube? You have to multiply the right hand side by x. If you multiply right side by x, you have to multiply left side by x also. That is multiplying both the sides by x. Multiplying both sides by x. So what do we get? Therefore, x into dy by dx, x into dy by dx, which is equal to, now on the right hand side, minus, now multiply by x here, minus 3x cube log x, minus 3x cube log x. Right hand side is also multiplied by x, minus x cube, minus this is your x cube. Is that clear now? So, or now here you can write x into dy by dx, x into dy by dx is equal to minus 3. Minus 3 into what is the value for x cube log x? Yo x cube log x भनेको थियो minus y. X cube log x को value हामी कसरी निकाल्छौं? This minus is taken to the left hand side, so it becomes minus y. So what is the value for x cube log x? It is minus y. Is that clear? Then it is minus x cube remains same. Is that clear to all of you? So or x into dy by dx, x into dy by dx is equal to, now multiply them, minus into minus plus 3y minus x cube. Okay, now this 3y is taken to the left hand side, so what does it become? X into dy by dx minus 3y is equal to minus x cube. Okay, now again you have to differentiate both the sides with respect to x to prove this required result. So again differentiating both the sides with respect to x. Okay, again differentiating both the sides with respect to x. So what do we get? Therefore, for x into dy by dx you have to use UV rule. Keeping x as it is, differentiate dy by dx, d2y by dx square, plus, now differentiate x with respect to x, that is 1, you know that, and dy by dx remains same, dy by dx, minus 3 into, now differentiate y with respect to x, that is dy by dx, dy by dx is equal to minus, what is the differentiation of x cube? It is 3x square. So I think you have understood it. So next, or d2y by dx square, d2y by dx square plus dy by dx minus 3 dy by dx, different sign you have to subtract them, so it is minus 2 into dy by dx. Is that clear? And then you can take that minus 3x square to the left hand side, so it becomes plus 3x square is equal to 0. So we have got the answer, but instead of d2y by dx square write y2, and instead of dy by dx write y1. So it is, oh sorry, this is x. There is x here also, isn't it? You can write here x, or right, or you have to write x into d2y by dx square. So x into, what is d2y by dx square? It is y2, minus 2 into, what is dy by dx? It is y1, then plus 3x square, which is equal to 0. So it is proved. So I think you have understood this problem, so you can copy it. Okay, so this much is for today. आज हामीले जति पनि प्रब्लमहरु गर्यौं, यो सबै सेकेन्ड अर्डर डेरिभेटिभको प्रब्लम र फर्स्ट अर्डर डेरिभेटिभको प्रब्लमहरु छ। यसलाई सबैलाई तिमीले घरमा रिभिजन गर्नु, बुझेन? अनि जुन चाहिँ होमवर्क दिएको छु त्यो पनि गर्नु। So in the next online class we will do more problems on this type of questions. So this much is for today.